we can find the distance between 2 points in the coordinate plane with the distance formula. The distance between the points x sub 1, y sub 1, and x sub 2, y sub 2 is given by d for distance equals the square root of the quantity x2 minus x1 squared plus y2 minus y1 squared. Or in other words, find the difference of the x-coordinates, square that, the difference of the y-coordinates, square that, take the square root of the sum of what you get, and that's the distance between the 2 points. Real nice simple formula to use. Now, the equation of a circle with a center at the point AB and a radius of r is given by x minus a quantity squared plus y minus b quantity squared equals r squared. Now, this formula for the equation of a circle comes from the distance formula, and if you want to see the derivation of that, you're going to have to look in the book. All we want to do in the video lesson here is see if we can use these two formulas. So first, let's look at an application of the distance formula. I want to find the distance between the points 3, negative 5, and negative 2, 1. So my distance formula says that that's going to be the square root of x2 minus x1, quantity squared, plus y2 minus y1, quantity squared. So the difference of the x-coordinates squared plus the difference of the y-coordinates squared, the square root of that sum. So I can assign this as the point x1, y1, or this as the point x1, y1. It really makes no difference. It doesn't make any difference what order I subtract in either. So I'm going to start by, let's do this, negative 2 subtract 3, quantity squared, plus, let's go 1 subtract negative 5. So that'll be 1 plus 5, that quantity squared. So I end up with the square root of negative 5 squared, which is 25, plus 6 squared, which is 36. So that gives me the square root of 61. Now 61, I can't simplify that any further, so I'll just leave this as the square root of 61, or with a calculator I could find a decimal approximation to this. So I took negative 2 and subtracted 3. I could take 3 and subtract negative 2. It won't make any difference because that difference is in parentheses and then squared. So since I'm squaring that difference, if I subtract in a different order, I'll just get a positive 5 instead of a negative 5. But whether it's negative 5 or positive 5 in there, when I square it, I'm going to have 25. So it's a real simple formula to use. The difference of the x-coordinate squared plus the difference of the y-coordinate squared, the square root of that whole sum. In this case, I get the distance between the 2 points as square root 61. For problem number 2, we want to find x so that the distance between x2 and 1, 5 is square root 13. So let's use our distance formula. The distance between this point and this point will be the difference of the x-coordinates squared. So I'll take x minus 1 squared plus the difference of the y-coordinates. 2 subtract 5 is negative 3 squared is 9. That's equal to square root 13. So the distance between these 2 points is square root 13. So I apply my distance formula to the 2 points and I get this expression. I know that's equal to square root 13. Now let's see if we can solve this equation. I'll do that by squaring both sides. If I square both sides of the equation, I get x minus 1, quantity squared, plus 9 is equal to 13. Now there's a lot of ways I could solve this equation. Let's just add negative 9 to both sides. I have x minus 1 squared is equal to 4. That means that x minus 1 is plus or minus 2. So x will be equal to 1 plus or minus 2. So I get 1 plus 2, which is 3, and then I also get 1 minus 2, which is negative 1. So I end up with 3 or negative 1 as the two values of x that I can put in here and have a point so that the distance between it and 1, 5 comes out to be square root 13. So two possibilities here, 3 and negative 1, each of which will give me a point that is square root 13 units from the point 1, 5. Next, I want to work with the equation of a circle. I want to find the equation of the circle with a center at 3, negative 2, and a radius of 3. So my equation for a circle is this. X minus a squared plus y minus b squared is equal to r squared, where the point AB is the center of the circle, and the radius is r. So r is equal to 3, a is equal to 3, b is equal to negative 2. So I'll substitute these numbers into my equation, and I'll have this. X minus 3 squared plus y minus a negative 2, which will be y plus 2, squared is equal to 3 squared which is 9. So x squared, or I should say x minus 3 quantity squared plus y plus 2 quantity squared is equal to 9. Now, if I was given this as the equation and asked to find the center and the radius, I'd be looking at the coordinates of the center and at the square of the radius. So I would say the center is at 3, negative 2. It's always the opposite of where signs are right here. And the radius is going to be equal to the square root of the positive square root of this, which is 3. So if I'm given the center and radius of a circle, it's easy to find the equation. And if I have the equation in this form right here, it's easy to find the center and the radius. What I want to do next is graph a couple of circles. I'm going to graph the circle x squared plus y squared is equal to 4. Now this has the form x minus 0 squared plus y minus 0 squared is equal to 2 squared. So I can tell by looking at it this way that the center is going to be at 0, 0. So let me see how I want to write that down. The center is at 0, 0, and the radius is equal to 2. Okay, so here's the center right here. The radius is equal to 2, so I go 2 units out in every direction from the center at 0, 0, and see if I can draw a reasonable circle here. That's not too bad. There's a circle with a center at the origin and a radius of 2. So given the equation of the circle, if I can write the equation in this form, I'll be looking at the coordinates of the center and also at the radius. So it's x minus a quantity squared, y minus b quantity squared is equal to 2 squared. So a and b are the coordinates of the center, and r is equal to the radius. Let's try another problem. So here I have x squared plus y squared minus 6y is equal to 7, and I want to write this in a nice form. So what I'm going to have to do is complete the square here on these y variables. So this is x squared plus y squared minus 6y, and I'm going to leave a little space, is equal to 7. Now I want to complete the square on y, so what I need to do is add, well, let's see. The coefficient is 1, this is negative 6, half of that is 3, the square of which is 9. So if I add 9 right here, this will become a perfect square. If I add 9 to one side of the equation, I have to add 9 to the other side also. So I end up with x squared plus this then becomes y minus 3 quantity squared, and this side is 9 plus 7, which is 16. So it looks like I have a circle that has a center at x equals 0, y equals 3, and a radius of 4. So let me see if I can draw this circle now that has a center at 0, 3 and a radius of 4. Let's take a look. So the center is at x equals 0, y equals 3. So x equals 0, y equals 1, 2, 3. And now I have a radius of 4. So I have to go 1, 2, 3, 4 units that way, 4 units down, 4 units back, and then 1, 2, 3, 4 units up. So I'm going to get a circle that looks something like this. Can't draw a circle very well by hand, but that'll have to do. Okay, so does that look like a circle that has a center at the point x equals 0, y equals 3, and a radius of 4? It does, and you can see that it's easy to graph the equation of a circle if it's in the standard form for the equation of a circle. X minus a quantity squared plus y minus b quantity squared is equal to r squared. Then a and b are the coordinates of the center, and r is the radius of the circle.